In this video we're going to look at substituting into algebraic expressions and equations and formula. We've got an expression here, 4a take away 3b plus 11, and we're substituting in a equals 6 and b equals negative 2. Main thing we have to take into account here is order of operations. So when we substitute in, this becomes 4 times 6 take away 3 times negative 2, and I might put that in brackets because of the negative sign, at 11. Okay, we've got to do the multiplying first because of our order of operation rules. 4 6s are 24. Now 3 times 2 is 6, but a negative times a negative makes a positive, and then plus 11. So that becomes 30 plus 11, which is 41. The second question, we have an equation y equals x squared plus 4x take 5, and we're asked to evaluate y when x equals 11. So that means we're going to get y equals 11 squared plus 4 times 11 take away 5. Now, because of order of operations, we have to do the squared first. 11 squared is 121. And we can do the multiplication at the same time because it's a separate term. 4 times 11 is 44. Take away 5. So that becomes 165 take 5, which is 160. Third question. We asked to evaluate the square root of p squared minus q squared when p is 6 and q is negative 2. So that's equal to the square root of 6 squared take away, and I'm going to put brackets for the minus 2 squared. So that's the square root of 6 squared is 36. We've got to do the squared first. And negative 2 squared, remember, negative 2 squared means negative 2 times negative 2, which is positive 4, and the minus sign still stays the same, or subtraction sign still stays the same. So that is equal to the square root of 32, and that's approximately equal to 5.66 to 2 decimal places. We're asked to evaluate this expression, which contains some pretty nasty exponents. Now, just writing this out, substituting our numbers, f to the 0.5 is going to be 6 to the 0.5 over 3 times f, which is 6, times g, which is 0.7 to the power of 0.25. Now, in our order of operations, we need to do our exponents first. Now, we're going to use, depending on your calculator, but on most scientific calculators, you'll use y to the x, or you'll use that little up arrow or up hat button. So 6 to the 0.5 turns out to be 2.45 over 3 times 6 times, and 0.7 to the 0.25 is 0.915, and then doing, if we just multiply the denominator out, that's 2.45 divided by 16.46, and that becomes, when you do that division, 0.149. Okay, now we're going to substitute in a fairly awkward looking expression. We need to work out what capital R is given E, I, P, R1 and R2. So this becomes E over I is 11.2 over 0.85 plus R1 times R2, that there's an implied times there, so it's 12.4 times 0.52 over R1 plus R2, which is 12.4 plus 0.52 plus P, which is 10.9 on I squared, which is 0.85 squared. Now, I'm going to have to abbreviate this a little bit because of space. 11.2 divided by 0.85 turns out to be 13.18. We need to do those divisions and all that. The final bit will be adding. In the next term, we need to, depending how you go about this and how good you use your calculator, you need to add the two numbers in the denominator and store that in your calculator, and then work out the numerator and then divide by the number that you stored in your calculator. But I'll let you worry about that. That comes out to 0.499. And with this one, we need to work out what 0.85 squared is. And we need to save that or write that down and then do 10.9 divided by that. So it would be possible with this one to do 10.9 divided by 0.85 squared on your calculator, and your calculator will do the squaring before it does the dividing. Most modern calculators have got the order of operations part worked out fairly well. That comes to 15.087. So by the time you add those, we get 28.766.